Live from an obscure area somewhere in Northern California, this is Miss Miller's Math Show, with your host, an engineer technician turned public servant for education from Cuckoo Cachoo, California, Mrs. Miller, and the co-host, a public servant for education assistant from Slobodan, Nebraska, Crystal. Now, here's your host, Mrs. Miller.
There we are. Okay. All right. No, I gotta get you guys to do this. Sloan, I think we should dance. Dance for everybody. Oh, there we go. Yeah. Okay. All right, we will do some math today. Okay. All right, we will do some math. I know you all can't help it. You love math so much. Okay. So, here we are. Make sure we're all good. Let's go up a teeny bit. Okay. So, guess what we are doing today? I'll tell you this. Last period, this lesson lasted maybe 5 minutes. Maybe 10. What? I know. That's awesome, right? So, let's see if we can keep with that, okay? All right, so we're going to start out by talking about linear equations. This is super easy. It's another one of those that I'm afraid you all are going to overcomplicate, okay? So, a linear equation is an equation whose graph is a line. So we've done this before. It's actually kind of a review, except for the first part. Whose graph is a line. And one of the things that we want to get good at is identifying the difference between a linear equation and a nonlinear equation. So we're going to go through and make a couple lists here, okay? Linear, nonlinear. Okay, so we're going to, this list that we're putting together, it's going to be our criteria that we're going to go through and check some equations by. Okay, so a linear equation has one or two variables in it, and there can actually be 3 variables, but we don't get into multivariable things until later on if you want to do like higher levels of calculus and whatnot. Yeah. How many of us would like to go on to calculus? Yeah. Yay! Oh, yeah. That's like like a third of us. That's awesome. Okay, next, no exponents. No exponents. So again, what we're going to do is use this list and go through and look at equations and see if we can pick out which ones are linear and which are not. Next, there are no variables multiplied by each other. And we have no variables in the denominator. So remember, a variable is just a fancy word for letter. Okay, so no variables in the denominator. All right, so that's our linear list. So check this out. This is the nonlinear list. The nonlinear list is anything that is not in the linear list. Isn't that good? Okay, anything, we're actually going to write that down. Anything that is not in the linear list. Okay, so here we go. How does this apply to what we are doing? We are, the first set of examples that we're going through. Am I going too fast? Am I going at warp speed? Okay, I can take a break. I can tell you all, well, so for the people who are done, this is your entertainment. I'm super tired. My daughter was up at 3:30 last night, which meant I was up with her. And she has this thing where she likes to play with people's faces. She's exploring, right?
She likes to does she do little rubbing things?
She sometimes, yes. But her big thing is this. She does this for herself, and she's starting to do this with me too. She goes like this. She goes, or ba 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 ba. So that's her big thing. So last night at 3:30 in the morning, she's laying on my lap, and I am like dead tired. Like, child, go back to sleep. And she goes, with her hands, she's like looking up at me and going on my face. So I just turn my head away, try to will her back to sleep. And then she gets her head right in my face and smiles like, hello, I'm here. Yes, please,
just
go to bed.
Thursdays are
my suggestion to all of you, I love my daughter dearly. She's just like so awesome, but wait as long as you can to have kids. Or never if you don't want kids. Okay, here we go. Which of the following equations are linear and if it is not linear, give a reason why. And actually we can just circle because it'll become very obvious which ones are and which ones aren't very, very quickly here. Okay, so we're going to do two together and then I will have contestants. What's up, Zach?
We don't know the last word on the linear.
This?
Yeah.
D-E-N-O-M, that's short for denominator, so no variables in the denominator. Thank you for clarifying that. Okay, here we go. The first one, we are literally going through and saying, is this linear, yes or no? So I'm going to move this down again just so we can see our list here. Linear versus nonlinear. Okay, so variable, fancy word for letter. In this, do we have one or two variables? Yes, we have one. Okay, are there any exponents? No. Are there any variables multiplied by each other? Nope. And are there any variables in any denominators? No. So this is, you can just say yes, this is a linear function. So let's go through and do one more, and then I'm going to ask for some contestants, okay? Next one is 8 plus 4xy equals 10. 8 plus 4xy equals 10. All right, so again, going through our list, do we have one or two variables? Yes. Do we have any exponents? No. Do we have variables multiplied by each other? Yes. Where are the variables multiplied by each other? So you can circle that, point to it, and say no. No, that is not because of the variables that are multiplied by each other. That is the extent of it. Questions? Sloan.
So, okay, let me just write. Because the variables are next to each other, that's why it's a no. But say it was just x and variables around it, and we could like switch them over to sides, then it would be yes, right?
Correct, unless you have to divide those variables, which puts them in the denominator, which also means it's not linear. We're going to do a few more examples, okay? Noel. Like this?
Yeah.
Is that what you were asking, Sloan?
Yeah, I was asking like if it was like that, then can we just get the x by itself? And
Yeah.
Then it would be yes.
Correct. Yep, that's correct.
But what if it's x and y?
Like a y here. Okay, are they multiplied by each other? No, they're added, so this is still linear. Does that make sense?
So if the two variables are multiplying by each other, then it's not.
Correct. If the two variables are multiplied, and so multiplied variables are literally variables that are smashed together. Okay? Questions? Okay, let me put a couple more up here, and then I'm going to ask for some contestants, all right? So here we go. The third one is 2x squared minus 3y equals 10. The fourth one is 11 equals 1 over x. And the fifth one is negative 7 equals x minus 3y. So let me write them on the opposite side, and then I'm going to ask for some contestants. So again, 2x squared minus 3y equals 10. 11 equals 1 over x. And negative 7 equals x minus 3y. All right. Do we want to take a break, or can we do contestants right now? Right now? Okay. Shuggy, do you want to come up, or do you want to do it from there? She'll come up. All right. So, oops, let's get our music cued. Everybody give it up for Shuggy.
Woo!
What is this stand for? Working with garbage disposal or something?
Yeah. Here we go. Yeah. Here we go. I'm talking about man.
Okay, clap if you agree with Shuggy. She said no because of the exponent. All right, everybody give it up for Shuggy. All right, how about the next one? Who wants to come up for the next one? Noel. Okay, come on up, Noel. Everybody give it up for Noel. Okay, clap if you agree with Noel.
So what?
He said no. All right, good. Last one. Let's come up. Let's have Alex on up. All right, everybody give it up for
All we gotta
Alex.
do was put in a little practice from the plumbers and the teachers, and even the physicians, the doctors and the lawyers, and even the musicians counting down. Like 1,
Right,
2,
he
3,
says
4.
yes.
We
Clap
can
if
hear
you
it on
agree
the
with
beat and
him.
even read it on the score. Some say a waste of time. What are they doing?
All right, thank you, Alan. All right.
Sleeping up the floor.
All right. Questions?
New.
Yes, Sloan.
So number 5 is yes because the variables are subtracting.
Exactly. Perfect. She said that the last one is a yes because the variables are subtracting. That's perfect. Yep. Questions? Okay, next few problems are totally review. What do we think about that? That is awesome, right? Review is good. It's nothing new. Okay, here we go. We are graphing again. Graphing is something, it's a skill that you will need for a very, very long time. So, we want to make sure we have it down. X plus 3y equals 9. We want to graph this. All right, so I'm getting over a cold. I'm going to get a Kleenex while you all write that down and draw a graph on your paper. X plus 3y equals 9. Alyssa? Excellent. Yeah, if I heard you correctly. She said, are we going to have to put it in slope-intercept form? Is that what she said? Yes, that's exactly what we're going to have to do. So, Alyssa, how do you think we're going to do that? Or do you want to start us out? So, slope-intercept form is just getting y by itself. So how would we go about getting y? Good. Subtract x. Everybody give it up for Alyssa for that. Everybody give it up for Alyssa. Good. Okay. Crystal, do you still have my sheet? Could you also keep track of people while we are in here? Thank you. Okay. Next, you can also write this as 9 minus x, but slope-intercept form we do x first, typically, the slope first, and then y-intercept second. All right, who can tell me what the next step is? Yes, Tyler.
Divide by 3.
Excellent. Divide by 3. Let's not have a blackout. Yes. Yep. Divide everything by 3. They cancel out here, and we end up with negative 1/3 x plus 9 divided by 3 is 3. That's what we want to graph. Okay, so let's everybody draw a graph on your paper. What's that? If you don't have graph paper, that's fine. Just draw a little one on your paper. Okay, so can someone tell me how I go about graphing this? What is the first step? Rebecca.
You go over 3.
Over 3 in which direction?
Right.
To the right. Clap if you agree with Rebecca. Going to the right 3. Clap if you disagree with Rebecca. Clap if you're not really paying attention. Okay, so this number again represents the y-intercept. So the y-axis is up and down. So we're actually going to go up 3 first. Good. Okay. Then from there, what do we do? What would be the next step? Sloan.
Well, this is it's a negative, so do we go down 1 over?
Exactly. Perfect. She said because it's a negative, we go down 1 and right 3. Everybody give Sloan a round of applause. And connect them. Questions? Questions? Okay. Let's do one more of these, and then one more after that, and then one more after that. Okay, Sloan, what's up?
So when we set up the equation, what you want us to do is to get y on the outside.
Yes.
And x, and then just the variable.
Yes, exactly. So we want to get, when we're graphing these, we want to get y by itself, everything else on the other side. Yep,
Okay.
exactly. Other questions? All right, I'm switching the paper. Here we go. We've got 3y minus 3 equals 6x. Okay, so who can start me out if I want to get y completely by itself here? Thane. Add 3. Perfect. Give Thane a round of applause, or give it up for Thane. Good. Okay, now what? What? Is the y completely by itself yet? No. So, good. Okay, give Thane a round of applause again. Divide by 3. Y equals, okay, so we want to go through and divide these. 6 divided by 3 is what? Whoa, okay. Hold the phone.
Oh.
Everybody listen up. That was scary. Ready? Okay, everybody better get this right. I'm scared. I'm scared to throw it out there. Are you all ready?
Yes.
Okay. What is 6 divided by 3?
2.
Okay. Thank God. That was scary. Okay, let's do this one. Make sure we're all awake. What is 3 divided by 3?
1.
Okay, good. Give yourselves a round of applause. That is, whoa, okay. All right, here we go. So, can somebody guide me through graphing this one? Olivia.
You go up one,
Perfect.
and then you go up two and over one.
Good. Everybody give it up for Olivia. Thank you, Olivia. Okay, how are we doing on questions? Any questions? All right. Last 2 problems. These need to be on here because otherwise you all are going to get to the homework and be like, dude, Miss Miller, you did not teach us this. What is up? So we are going to take care of it right now. All right, y equals 5. Oh, my. So these are actually the easiest kind of problems to graph, and somehow everybody always still gets them wrong, which is a little scary. Samantha. Good. 1, 2, 3, 4, 5. And what do I do with that? Do we shade? Do we... Good. Okay, good. We do a horizontal line. So you're saying essentially you're cutting through the y-axis at 5 up. All right, everybody give it up for Samantha and for Alyssa and Cole, who all contributed to that. Okay? So if y equals a number by itself means you cut through the y-axis at that number, what do we think x equals a number by itself is going to look like? Cole? Good, perfect. Give it up for Cole. So x equals -2. Let's do that. And then we will call it a day. I mean, don't get me wrong. I know you all would love to just sit here and do math problems over and over again. But seriously, guys, contain yourselves. Contain yourselves. Okay.
Like Mr. B used to say that. Just calm down.
Just calm down. That's right.
He's the only one calling out.
Okay, so x equals, I could sit and watch Mr. B teach all day. I think he's like an amazing teacher. Okay, x equals -2. How do I do this one?
Easily.
Tyler.
You go over to the left,
Good?
and then you just draw the 9.
Good. Everybody give it up for Tyler. Go to -2 on the x and cut through the x-axis. Okay, you guys, are there questions? You have a ridiculously easy assignment to work on tonight. I'm actually telling you that last period, as soon as I wrote the homework assignment up here, people brought it up and were like, I am done. In like a second.
I'm done. Okay, done.
You're done. Okay, right. I haven't given you the assignment yet, and you're already done. Okay, homework 15, page 125, numbers 4 through 32, multiples of 4. If you guys happen to talk to the Accelerated Algebra 2 kids, they have a group test tomorrow. Send them your love and best wishes from my house to yours. You guys watch the Food Network?